Hello again. So now we have a completely blank table, and we want to fill it out for the since it's a down arrow, it'll be a disjunction P or and then not R. So you can see it's all blank. So we even have to create the header so we know what we're doing. I start these out same way every time. It might not be the most efficient way. Other teachers or professors kind of have different styles to it. I just like keeping it this simple way so that I always know how to organize it every time. So the first thing I do is include a column for each statement involved. So P, Q, R, whatever. Well, a P is involved, so let's head this column with the P statement values. We have a not R, but like I said in the last video, the value of not R always depends on what the value of just R is. So I actually want to make an R column first. And then once I take care of that first part right here, where I just list the regular unmodified statements, then on the next columns I'll write are the negations of statements. So like not R would go next. And in the last column, that should be the entire compound statement that we're trying to find. So that's P or not R. The way I do this is, again, since I've listed the regular P and R statements unchanged, I'm going to start those first two columns out like they were in the last video, where I list every combination of values that those two statements could have. So they could both be true. One of them could be true and the other one could be false. So P could be true, R could be false, or P could be false and R could be true, or both statements could be false. And you'll see whenever I'm just using two statements, my first two rows will look like that every time, every single time. So then we have the not R column, which is, I'm just going to take the R column and do the opposite values. So if R is true, not R is false. If R is false, then not R is true. R is true again, so not R is false. And lastly, R was false, so not R is true. So they're inverted from each other. And then finally, I can do the entire compound statement P or not R. The or means it's a disjunction, so only one of those two have to be true in order for the entire disjunction to be true. One little trick I do is look at each kind of part of your disjunction. P, right? I'm just going to put a little 1 there because I'm going to use a P. The other part to it is the not R, so that's 2. So one way I could think of this, if you don't like all this kind of letter stuff going on and all the squiggles and stuff, is you could just think of it like this. Take column 1 and join it as a disjunction with column 2. So that way I can really ignore that column altogether, but you need that column to get the not R column. So it is useful. But when you're evaluating the last step, or really any step, the most you should be looking at are 2 columns at a time, never more than that. So let's look. Column 1 and column 2, since it's a disjunction, only one of them needs to be true for the entire disjunction to be true. So for P, that has true, not R is false, that means the disjunction's true. The next row, P is true and not R is true. They're both true, so the disjunction's true. Now, in the P column, it's false In the not R column, that's false. That means now the disjunction will be false since we have two false statements. And then finally, we have that P is false, but not R is true, which means the disjunction is definitely true, since at least one of them was true. And hopefully you get the hang of what I'm doing, especially after another example. You'll start to see the kind of logic behind it. So let's try out another one. Not P and Q. So like I said, I'm just going to write out the regular P letter, then the Q letter, then the negation values go next, and then the entire thing, not P and Q. All right. The first two columns, exactly the same each time. Either they're both true, one of them's true and one of them's false, or they're both false. The not P column is just the opposite of the P column. So P starts out as true, that means not P is going to start out as false. P is true in the next one, so not P is again false. In the last two, P is false, so not P will be true. So then finally, we have this last one, not P and Q. I'll just mark this with like a little 1. And the Q column will be like a little 2. And then think of this as the conjunction of those two columns. We can ignore the P column at this point. So conjunctions, those and statements, are true when both of those component statements are true. So in the first row, we have true, false. That means it's going to be false. Double false gives us false. Now we have Q is true and not P is true. So that's actually going to become true. And then we have Q is false and not P is true. So that means it's going to be false. So that's how we can evaluate those results. In the next video, we'll go over a bit more complex problems. So stay tuned for that.